He's in OpenStax Calculus Volume 2. We are in Chapter 3, working on Section 3.1, Integration by Parts. The integration by parts is a method that takes one integration problem apart and kind of manipulates the parts to make it a new problem that's easier to solve. Easier being a pretty relative term, because I'm not sure how easy you're going to find this to start off with. Once you get used to it, I don't think it's too bad. But we have two separate functions. U is going to be our f of x, and v is going to be our g of x. So what's going to happen is the first problem is going to be u dv. So think of that like f of x times g prime of x. And what we're going to do is we are going to find f prime of x and find g of x, which means working backwards from each other. And that's going to set up our problem as f of x times g of x minus the integral of g of x du, which is going to be f prime of x. So in other words, we're going to let u equal f of x, and we're going to let dv equal g prime of x. Then from that, we're going to find du, and we're going to find v. So we're going to take the derivative of f of x and the integral of g prime of x to find all the parts that we need to set our problem up. Now, when you first say it that way and you look at the rules, you're like, holy Moses, that's not going to work. I don't know what we're doing exactly. But then we look. Here, they gave you what you need to set this one up. Like they told you which parts are which to go with it. However, we are going to talk in a few minutes about how to figure out which one you should use for what. So, if I say that u equals x, then du is dx. We know this. If dv equals sine x dx, then v, if I integrate sine, is negative cosine x. Okay, that was the backwards, the integration rule, not the derivative rule. We worked backwards. So now you rewrite your problem as not the integration, that was wrong. U times v minus the integral of v du. And a lot of times you're going to see where your u is a simple variable and your du is a dx. So it kind of takes that extra variable out. Now here we have negative x cosine x. Cosine, when I take the integral, is positive. So I'm going to take this negative out. So that's going to make it plus. The integral of cosine is sine x plus c. And that's our answer. All right. Now, let me find it. There is an acronym that is used to help figure out what to do. LIATE, which I don't think is a real word, but I didn't look it up. But instead of just taking wild guesses on what you should do, this, let's call it LIATE because I don't know what you're going to actually name it, represents logarithmic functions, inverse trig, algebraic functions, trig functions, and exponential functions. And this serves as an aid in determining what should be your u. Now, does it always work? Not necessarily. However, it is at least a jumping off point to figure out what's going on. All right, so looking at this one, using integration by parts again, we have the integral of ln x, or natural log of x, over x to the third dx. They rewrote theirs, and this happens a lot because we don't do a lot with the quotient, with x's in the bottom of here. So we rewrote this as x to the negative 3 ln x dx. Okay, Now, if you remember, the very first thing in our little list was log functions. Len is a log function, so I'm going to let this be my u. So u is going to be len x. That means that du is going to be 1 over x dx. Well, that also means that dv is x to the negative 3 dx. So if we work backwards, then v equals x, take your power up 1 and divide by the new power, right? So if we rewrite now, we have u times v. I'm going to rewrite it as minus the integral of v du okay? So if I keep going here, I can just rewrite this one as len x over negative 2x squared. If I pull out my negative 1/2 here, it makes this a plus. 1 over x squared times 1 over x is 1 over x to the third, which we already told ourselves earlier was x to the negative 3. So now we're going to have len x over negative 2x squared plus 1/2 times x to the negative 2 over negative 2 plus c. Len x over negative 2x squared plus, nope, minus, because when you multiply by that negative down here, x, nope, 1 over 2 times 2 is 4, and the x to the negative 2 is going to come down and be x squared plus c. And that's it, guys. Not saying it's easy. I'm just saying give it a try, break it up into pieces, and see what you can do with it. All right, let's look at example 3.3. Here, x squared e to the 3x. Well, we had log functions, don't have any inverse trig functions, don't have any algebraic functions. That's where x squared comes in. So if we say that u is x squared, then du is 2x dx. If v is e to the 3x dx, nope, where I'm going to get my world in order, dv is e to the 3x dx. So guys, I'm going to come over here to the side. If I integrate e to the 3x dx, my u is 3x, my du is 3 dx. So that tells me I need a 3 here, which means I need a 1/3 here. So 1/3 e to the u du is 1/3 e to the u. So that's what v would be, 1/3 e to the 3x. Okay? Now, our problem. U, v, minus integral of v du. All right. So, love throwing some crazy stuff in here. 1/3 x squared e to the 3x. That's the order I write it in simply because it's the way I prefer it. I'm going to take out my 2 and my 1/3. So 2/3 integral x e to the 3x dx. Okay? Here's the problem. I still have x and e to the 3x. So I have to do integration by parts twice on this one. So my u is going to be x, my du is going to be dx, my dv is e to the 3x dx, which we've already done, so v is 1/3 e to the 3x. Okay, so stay with me. You got to put all this stuff together. I'm keeping this 1/3 x squared e to the 3x over here minus. I'm going to put my 2/3 right there. U v minus v du. Now I'm down to just one thing that I can integrate. Okay, so I'm going to have to start going this way. I have 1/3 x squared e to the 3x minus 2/3 times 1/3 is 2/9 x e to the 3x minus, I'm going to multiply this 2/3 here. I'm going to take out a 1/3, right? Let's fix this real quick before I do that. Because I know I can do e to the 3x dx. I know that that gives me this. But let's take this 1/3 out, okay, and multiply it by this 2/3. That's 2/9 again, times integral of this from up here is 1/3 e to the 3x plus c. Now, to finish off our answer, 1/3 x squared e to the 3x minus 2/9 x e to the 3x minus 2/27 e to the 3x plus c. All right. Keep in mind that even though there are a lot of parts to this, none of the parts are especially hard. It's just a lot going on. All right, talk about the next one. Integration by parts when our liate or liate or however you want to say it does not quite work. This is algebraic, but if I say u equals t to the third, du equals 3t squared dt, I have a t squared, but it's in my power. So what's going to happen here? Well, my dv would be e to the t squared dt, but we can't take the integral of e to the t squared dt. It just doesn't work that way. So this one you have to do a little bit of creative math with, okay? So, sorry, I'm trying to make sure I'm bringing you everything you need. If u is t squared, just stay with me, then du is 2t dt. I can put a 2 in here, but I can't put an extra t. So what we do is we take this apart. Okay, so I'm going to rewrite this as t times t squared e to the t squared dt. All right, so this t squared is my u. My dv is t e to the t squared dt, because if I wanted to integrate that, and I said I'm not going to use u and I'm not going to use v because they're already over there. Let's do f. F is t squared, right? df is 2t dt. I have a t, but I don't have a 2, so I'll put that there. So now I have 1/2 integral e to the f df, which is 1/2 e to the f plus c, 1/2 e to the t squared plus c. So v equals 1/2 e to the t squared plus c. I recommend that you go back and watch that a couple of times until you figure out exactly how it worked. Now we can look and say u, which is t squared, v, 1/2 e to the t squared. We don't need the plus c yet. That comes at the end. Minus integral v du. Now, my first instinct was always to multiply the 1/2 and the 2 there and simplify. But if you remember right, I'm going to need that 2 to make this work. So I'm just going to take the 1/2 out here. So when I rewrite, I have 1/2 t squared e to the t squared minus 1/2 integral e to the t squared times 2t dt. Well, this right here told me how to integrate that. So I have 1/2 t squared e to the t squared minus 1/2 e to the t squared plus c. Now, if you need to, like I said, go back and watch this from up here. All right, we're going to stop right there for this video.